Okay, this is the last video of the multiple choice questions. We're going to look at questions number 33 and number 34, and there's a common theme to these questions. One of them is about what we would call linear momentum or translational momentum, and the other is about angular momentum. And the common theme is to think about what the system is and what are the properties of the system. Okay, so in this first one, question 33, we've got a spaceship with a detachable pod that's moving to the right with a velocity of v. And you get some information about the mass of the pod and the mass of the spaceship. And then the pod is released with some velocity still to the right. And the spaceship itself is now moving to the right with a velocity vf, which is greater than v. V was the velocity of the collective spaceship and its pod. But here's the swerve right at the end. Which of the following is true of the speed vc of the center of the mass of the system after the pod is launched? So that is a clue. When they talk about the center of mass of the system, what we need to understand about the system, if this is our entire system, then things may change. Individual pieces within the system may change. But the center of mass of the system will move forward with a constant speed. So the entire spaceship is moving forward with a velocity v. Later, the spaceship is moving with VF and the pod is moving with a velocity VP. But if we could locate the center of mass and watch how it is moving, we would see that the center of mass continues to move with a velocity V. So there's a lot of distractors in here about like the mass of the pod and the mass of the spaceship and so forth. But it comes down to recognizing that the center of mass moves without any interruption unless there are outside forces acting on the system. But the system here is not subjected to any outside forces. These are pieces internal to the system, and they're having a reverse collision, if you will. But the center of mass is undisturbed, and the center of mass moves with a constant velocity. So started out with a velocity v. Center of mass has a velocity v after the two pieces separate. Okay, last question is question number 34. Again, there is a lot of information. We've got a disk that's rotating, a platform that's rotating without friction. There's a child with a mass m and a platform with a mass 5m, and that's fine information. But again, the question that's asked is one that's about the entire system. It says, what will result in an increase in the total angular momentum of the child platform system? So the only way that the momentum of this can change is if there's some external force that acts on it. So we're going to look for responses that say that some external force is acting on it. And response A says the child moves towards the center of the platform. Well, that's not an external factor. B, the child moves away from the center. Both A and B, you could imagine that the child itself could have some sort of different angular momentum because they're at a different distance, but the entire child platform system can't change unless there's an outside force acting on it. Outside torque, I should say more accurately. C, the child moves along a circle concentric with the platform, so following the dashed line that was shown. So it could follow that. Well, and that's fine. The child can do that, but it's certainly, again, not an external force. And then finally, D says none of the actions described will change the total angular momentum of the child platform system because none of them represent an outside force. So the momentum of the system remains the same. Okay, well, I hope you found that these discussion of these selected multiple choice questions has been helpful for you. Please come see me if you want to discuss any of these questions or others at greater length. Thanks.